Hello, my name is Kevin, and for my project, I created a Houdini tool, which I call the Houdini Scene Builder. So before I get into the tool itself, I'd like to give a little bit of background on what Houdini is. Houdini is a 3D animation and rendering software that is used in special effects departments for movies and video games. But today we'll just be focusing on rendering still images using Mantra. Mantra is a highly advanced renderer that is included in Houdini, and it's the main component of Houdini that my tool utilizes. So now I'll discuss what my tool actually does. It essentially takes an input file which contains a list of objects, and then it builds the corresponding scene in Houdini. So you could see the general format for the input file is one object per line. First, you specify the name of the object, its position, and then its attributes. So here are the format for each object's attributes, starting with three geometry objects, the sphere, the box, and the tube. They all share the same attributes. So they have XYZ values for rotation, scale, and of course position. I think these are self-explanatory. Now it also has a color attribute, which is just the RGB values for the color of the object. Now, if you want an object with no color, you can put a negative value for any of the RGB values. And last, we have the material of the object. So the materials are all of the materials included within Houdini's material gallery, which includes some pretty cool materials like bricks, marble, concrete, metal, and a lot more. So down to the camera, it just has a single attribute, the angle at which you want to point the camera. And lastly, we have three different lights. So all these lights share color and intensity. Now the directional light has another attribute called angle, which is just the angle at which you point the directional light. And the spotlight also has this angle of which where you want to point it, but also has cone angle, which is a parameter that essentially determines how wide the cone of the spotlight will be. So since the Mantra renderer uses ray tracing, I thought it would be interesting to compare some renders from our own ray tracing project, Project One. As you can see, there's four different spheres with different colors, light, and a plane. The four spheres are handled these first four lines. You have the position, the rotations are all 0, and the scales are all half-sized. And then you have the color RGB. So this is the blue sphere, this is the red sphere, this is the white sphere, and this is the green sphere. And then you have flat for the material, which doesn't mean flat shading. That might be confusing. I should probably change this to smooth because I think Mantra defaults to smooth shading. But this essentially just means that there's no material applied to the spheres. And box is what this plane is. Its position, rotation is 0. The scale is what kind of creates it, creates the plane, because we have 40 in the x, so it spans in the x, 70 in the z, so it goes all the way out, and then just 0.01, which is just a very thin box, so it's kind of like a plane. And the color is -1, so it has no color, or the default color, I guess. And then, yeah, we have the camera with its position, and it's kind of angled down. And we have the point light, its position is right over here, and it has a white light with 1 intensity. So for this render, we just add another point light right here. It's a purplish point light. As you can see here, offset -2 to the x, so it's over here. And these are the RGB values that make it purple. For our last comparison, we have a render that introduces shadows in our original ray tracer. So in Mantra, shadows are actually enabled by default. So for these past ones, I had to manually disable them to try and make them look more like Project One renders. But yeah, so these are just the default shadows in Mantra. So we have two spheres. One's red, one's blue. This one's the red one, this one's the blue one. And then we have the box, which is the plane, the camera, and then we have 2 point lights. One point light is high up above, has 7 in the Y, so it's somewhere all the way up here, which is what gives these shadows. And I assume the same for project one, these shadows. And then another point light that's kind of more off to the side, negative 2x, so probably like more around here, which kind of gives this shadow and this shadow. And as far as the differences between the two, besides for the specular highlight differences, this shadow caused from the light over here is a lot more visible in my render compared to Project 1 renders. You could kind of see it, it's right there, but it's a lot less visible. From those comparisons, I was able to show you spheres and point lights, but now I'd like to try and demonstrate the rest of the objects that I support. So in this render, we have just 4 objects, 2 boxes, a camera, and a directional light. The first box is this brick wall. So you can see the material is bricks, which is what gives it this nice texture. The color is kind of a reddish orangish color I found, which adds to it being a brick wall. It's scaled 1.5 to the width, 2 to the height, and 0.1, so it's kind of a thin wall. And the second box is just this floor. It's scaled down so on the Y, so it's more like a floor, and it extends 20 on the X, so it's all the way over here, and then 10 on the Z, so it extends out, and -1 color, so it has the default color, and it has a concrete texture. And then we have the camera, which is just pointing directly at the wall, just the position, no rotation. And then we have finally the directional light, which is just a light angled down at -60 on the X. It's just kind of shining light down on the brick wall. In this render, the only thing we did was add a spotlight, a very intense spotlight. As you can see, I ramped up the color values and made the intensity 5, cone angle 1, so it's just a very bright circle on the wall. Finally, for this last render, I added 2 more objects, this tube and a blue point light in the middle of the tube. I think I'm going to give you a live demo on how to actually generate that scene with my tool, that scene that you just saw. So here we start off with an empty Houdini file, and then we can open up my tool, which is just fully contained in the Python source editor. If I had more time, I would like to actually make it its own tool, but for now it's just kind of living in the Python source editor. So it's just one big Python script. I'll briefly go over what the script does, but I define it in more detail in my project report, so I'll try to be brief. So the main functions are read file and reload scene. Read file reads the input file, parses it, takes all the objects, takes all the attributes, and then outputs them in these 2 lists. And then I pass these 2 lists into reload scene, which is basically just kind of deletes all the nodes that currently exist, so it doesn't like stack up if you keep running the script. And then it builds the scene, which just basically goes down the object list and finds which object it is, finds their attributes, and then calls the corresponding create functions, which are all up here, which basically do all the magic of creating the actual node and setting the parameters and yeah, all that. More detail in my project report. But yeah, let's run it. So the input file is called slideshow8.txt. So we just pass that in here. And we click accept. And voila, it builds the scene for you. So this is what it's like in scene view. and all the nodes are down here. So you could still kind of play with them if you want. And what I wanted my script to do originally was render the file for you, but I didn't have enough time to implement that. So you actually have to go and click this render button. Make sure you select the camera you generated. Click the render button, and it'll render that scene that I was just showing you on that slide. And this is going to take probably a while, so I will fast forward. All right, looks like it's done rendering. It took a whopping 10 minutes and 35 seconds, so you know Mantra means business. But yeah, that's my project for graduate computer graphics at UC Riverside. Thanks for watching.